everyone. Hello, DevConf. I'm so excited to be here. I feel incredibly lucky to be able to speak to the South African developer community, and I've been so grateful for listening to all of the other talks today. I'm Jessie Auguste. I'm a software engineer at a British cybersecurity company called CyberSafe. I'm the co-host of a technical podcast called Glowing in Tech, and I'm a member of the OWASP community. So I'm incredibly passionate about security and secure web development, and I think it's crucial that we all feel empowered to develop our best secure code. And to do that, I think we need to collaborate, and I'm hopefully going to share some things that will make it a little bit more fun to do that too. So thanks so much for taking the time to come and listen today. So the talk is going to be broken down into 4 different sections. I'm going to start with an overview of kind of secure software development in 2023 and what that looks like. I'll then move on to the barriers to having a secure software development lifecycle, and then we'll start to look at the tools that we can use to make it better, and finish on creating what it takes to create a secure software development culture. So, what is secure software development like in 2023? We'll start with the positives, and generally speaking, we've been making a lot of progress in the time that secure software development has existed. And so I'll start with the definition, which is that developing secure software is building software in a way that means that we are guarding against the accidental introduction of security vulnerabilities. We're also making sure that defects, bugs, and logic flaws are consistently the primary cause of commonly exploited software vulnerabilities. So making sure that we're doing everything we can to mitigate those. And then I want to talk about our responsibility as developers. So being a user-focused developer means that we're always advocating for the people using our applications, and so we should be building with their protection and the protection of their data in mind. And really, building securely is not a one-and-done thing. It is an ongoing effort that we all need to make sure we're continuing to do in order to protect people and their data from unauthorized use or harm. So, in the history of web application security, we're constantly adapting. We're developing new things, new technologies emerge, and with those new technologies come new vulnerabilities and new ways to attack and take advantage of that tech. So what the development and changes can look like is it's increasing the threat landscape, which is already incredibly vast. We're seeing that the pace of change can also be very quick and hard to follow, and then as a consequence, it can be easy for us to feel overwhelmed with a kind of doom and gloom perspective, which means that we're no longer feeling empowered to engage in it, because what's the point in trying if it's going to change so quickly? How can I stay relevant, and how can I stay ahead of the new threats and new vulnerabilities that are occurring? And so I really want to recommend an incredible talk, which is The Abridged History of Application Security by Jim Manico. I will have a slide with all the resources on at the end, so don't worry if you don't get it done. But I think this one is an incredible resource because it provides a fascinating perspective on not only how recent security testing and secure web development has existed, but also the incredible progress we've made and how fast we've been able to iterate on how we're working together. And in the past 20, 30 years, we've seen the emergence of a lot of open source communities that are coming together to share that knowledge and secure software applications through rapid iteration and collaboration. So it's great. We've seen loads of progress being made. There's more awareness of the problems and their solutions. And as I said before, that open sourcing that knowledge and those resources means that we're able to have a wealth of resources to refer to. We're also seeing tooling massively develop. And again, loads of free stuff available that allows us to create secure applications and automate a lot of that. And we'll be talking about some of those tools shortly. So DevOps and developer experience and DevSecOps, which we'll also cover, means that we're thinking about ways that we can minimize the amount of manual effort in securing applications. And that's been a fantastic wave of progress because it means that we're implementing security in every part of our build process. And then finally, we're seeing a massive increase in security-specific roles, which is a great indication that businesses are taking it more seriously because they're putting their money where their mouth is and investing in building secure products. So all of these are fantastic examples of ways that we're getting better every day in the industry. So we've also got the State of Software Security 2023 report by Vera Code, and that has a few really cool findings that I'm going to share as well. So the first of them is that 32% of applications contain security flaws at the first scan, so when they're very early doors just going into production, and then by the 5-year mark, the likelihood of finding a security flaw goes all the way up to 70%. So what that's telling us is that although security posture in the beginning is really important, we're also seeing that it's incredibly important to remain consistent with it, and we're falling short in that maybe we've got all the best intentions when we start a project, but as it gets more mature, as it gets more complex, it's a lot harder to maintain, and so we're introducing more flaws. Another finding from this report is, seems like an obvious one, but also a really important one to highlight, is just that more frequent scanning significantly reduces the probability of flaws being introduced. So we're seeing that automation and having these automated scanning is a really great way to make a significant difference in how resilient your application is. And we're seeing the rise of DevSecOps. So DevSecOps stands for Development, Security, and Operations. And what this is an approach to culture, automation, and platform design in a way that integrates security as part of the shared responsibility as opposed to just 1 or 2 people in the engineering department, because we're embedding security in the entire IT lifecycle. So tools, knowledge sharing, and security roles are improving. We must all be building incredibly secure applications, right? Not quite. So the study in 2021 by Immersive Labs has found that 81% of developers have knowingly released vulnerable applications. And I think it's quite a shocking statistic, but I don't think it should make us feel pessimistic. I think instead we should see this as a motivator for change. And I also don't think that this statistic is so high because developers don't care. I don't think it's a sign that they're not trying hard enough. I think it's showing us that there's a disconnect between this wealth of resources I was referring to, that all of the kind of like open source and collaboration, and then how that's being implemented in day-to-day developer roles. And so why do we have all this knowledge and how do we have it, but we still have the 81% pushing insecure code to production? And some of the things we hear from other developers and other engineering teams is about that overwhelm, that constant state of change and not being able to keep up, and that being a disempowering thing when you're considering security. So yeah, I'm now going to move on to the barriers and why that might be something. What are the things that are contributing to that statistic being so high? What are the barriers for teams building securely, and why do we have that 81% of insecure, knowingly pushing insecure software? So the first of which, a really obvious one, but lack of time. We know that developers are constantly under pressure to meet deadlines, and there's a constant battle between what we can delay until the next iteration and what we need for MVP to ship right now. And so that leads to shortcuts being taken in the development process. We see an increased risk of people needing to take those shortcuts, and that leading to the introduction of vulnerable code. So what that can look like practically is skipping some testing, not much prep and research into the considerations when we're scoping a feature, and then also using code or microservices that we haven't fully tested or fully vetted, but it works for now, we'll fix it later. The next barrier is the lack of resources. So we see quite often that organizations, although they want to be as secure as possible, are not providing developers with the resources that they need in order to write secure code. And so the lack of resources can refer to security tools, but also training and people power, that kind of decision from a leadership perspective to actually, yeah, we do need to spend some time going through our technical backlog. We do need to spend some time thinking about repairing some of those vulnerabilities that were flagged up in our pen test. And then finally, complexity. We all know and are part of building software applications that can become incredibly complex. And that makes it really difficult for us to address and identify those vulnerabilities. Where do we even start if we're so unsure of how all of these different components are even able to interact? What is the entry point for me as a developer to be able to make my code more secure? So those are some of the barriers, and now we're going to talk about how we can use tools to address those. So I've got a bias for open source tools because I think they're incredible, because they're accessible, they're driven by community and quite often are part of passion projects, and it enables a wide range of perspectives, often global perspectives, that are able to contribute, and that just leads to an incredible amount of information. So how can we use tools to improve security culture? Security tools are help to identify and mitigate security issues early in the development process. That's their goal. We want to use them to save us time in the long run and make us more resilient. So some of the benefits are that they provide increased efficiency and they help to alleviate the burden of repetitive tasks. They also can help to reduce human error. The automation can pick things up that maybe a human might not when we're doing code reviews. And then also they increase visibility. Quite often our security tools are able to provide us with real-time feedback, and we see that with SIEM tools that are able to provide us with event data that we can analyze. So what are some of these tools that we can use for vulnerability awareness? One of the ones I think is incredible to use is the OWASP cheat sheet. Life is too short, AppSec is tough, cheat. So it's a concise collection of high-value information and on specific application security topics. And what that looks like, this is like an example of one of them, and apologies if the text is really small, but it's about the authorization cheat sheet. So you've got the introduction, and then on the right is the table of contents. And in the table of contents, it starts with the intro, and then each one of those is like a section on a way that you can build resilience against this vulnerability. So it's an incredible thing. If you don't know anything about authorization, you're not sure how you can make it better, you can just search it up here, and it's an expert source list of all the things, the checkboxes that you can use to make sure that that's as secure as it can be. And then, so thinking back to the three barriers of resource, time, and complexity, this is really helpful because it can address all three by providing you relevant and actionable information based on a specific threat. And I think that's one of the key barriers as well for a developer who's unable to think of ways that they can implement more security practices in their day-to-day work is you need something that's relevant and specific and for that specific purpose. Otherwise, you can get lost in the wealth of knowledge that we have online. Next, I'm going to talk about tools for threat modeling. So this is possibly the cutest mascot for an app that I've ever seen. It is ThreatDragon, and it's another OWASP project. It is a free, open source threat modeling application that's built with the intention to be simple, fun, and engaging. And what it looks like is before building a feature, you can use this to draw a diagram of the data flow and how the data is going to move through your feature. And you record the possible threats, you record their mitigations, and you have a visual indication of the threat model components and threat surfaces. So you can see on the green lines showing where, the kind of trust boundary, and then the arrows being used to show the flow of data, and then the blocks to show, where your data is being stored. So it's a fantastic resource and a really easy thing to use too. If you want to know more about this, there's an incredible talk about it called Threat Modeling Gamification for Fun and Profit by Vlad Styron. And he's essentially going through all the reasons why and how you should use something like ThreatDragon. And I think it's put really well here. You cannot protect against something you don't know exists. So the benefit of using a tool like this is that even before you've written your first line of code, you're aware of the sensitive things you need to protect, you're aware of where they might be vulnerable, and you can, as it says in the diagram, it might be too small to see, but you can skip the peak of Mount Unaware, beyond the Valley of Despair, and you're doing that through increasing the knowledge of potential vulnerabilities before they even exist. So the barriers that this is addressing is the resource and complexity, because not only are you going through a really useful exercise either on your own or with your team, you're able to then share this diagram, a really simple visual representation of the thing you're about to build, and communicate it really easily. So where before it might be quite difficult to think of how just like think in your mind about how these different systems are interacting. Here you can have a diagram that shows the specifics of a feature and be able to communicate that with relative ease. Next, there is a tool for testing. And this is Zap. Again, it's a flagship OWASP project, which allows you to crawl a web application with its spider and passively scan every single page that it finds. The Zap then uses the active scanner to attack all of the discovered pages, functionality, and parameters. And I love how simple it is. It's literally just entering a URL. You download the app. It's free and open source. And it will give you a whole load of information about the vulnerabilities in an application. But please, please, only attack applications that you have permission to test. You can get yourself in trouble. So the barriers, if we go back to the barriers that developers face, this one can really help in saving time because, again, we're leaning on that automation. And it will provide resources through the knowledge of the known vulnerabilities, and it will provide that list. You can then use that to go to the cheat sheets. And the fantastic thing about this as well is it's intended for those who are new to application security as well as penetration testers. It's a fantastic entry-level way into trying to see what exactly is vulnerable. So I'd recommend doing this with any side projects that you have and just having a look at what you get back. And then another tool is a tool for gamification and education. This is the OWASP Juice Shop, and it's designed to be vulnerable to a variety of security attacks. It can be used by developers to learn and practice about security testing. And I think this is incredible because it's very playful. There's a lot of exploration, and I love the idea of being able to incorporate play and exploration into like bringing joy to something that can otherwise be quite a tricky thing to understand. So there are 101 challenges here, and they will have varying difficulty. You're supposed to exploit the underlying security vulnerabilities, and these are all built in a way that they would occur in real life and real-life apps. And yeah, like I said, it makes it fun. You can do this with an engineering team, which is a fantastic way to have a kind of like a bit of a nerdy social or like way to compete, because you've got a leaderboard that you can use with your colleagues or friends, and there are a lot of challenges. And like I said, it's a light-hearted, low-stakes way to engage with an otherwise intimidating topic. Another benefit is it's very friendly for entry-level people too, because there's a tutorial mode that gives you a guide for newcomers and kind of explains the vulnerabilities as it shows them to you. So, yeah, having tools to bring enjoyment and fulfillment to secure development. We use a wide variety of tools in our tech stack to protect us and make sure that we're resilient and to explore also what can otherwise be a dangerous thing to try and play around with yourself. And so we use a whole load of tools for compliance reasons, but we should also think about ways that we can use tools to bring joy to an otherwise difficult topic. I'm now going to move on to the creating a strong security culture. So what is security culture? What is a strong one? And how do we improve it? So security culture refers to the set of shared attitudes, values, norms, beliefs, and behaviors that influence an organization's approach to security. And I think it's really important that we think more about this because it's really easy to overlook and sometimes something that we don't consider in how it's impacting like we were saying earlier, with how applications over time can become more vulnerable, because even though we had the best intentions at the beginning, if we're not maintaining that security culture, we will be introducing flaws just because it's too difficult to engage with. So yeah, I think that one of the things we need is a mindset shift to privacy by design. And privacy by design, we'll go a little bit into the framework, but it's essentially changing the way you think about building in a way that means that we're thinking about the data we're trying to protect as the primary thing before we start building. So it's implemented in our design. Again, threat modeling is a great example of this, but making sure that we are advocating for the end user's privacy at every single stage, from deciding what we collect to what we're displaying to them in the end. So these are the 7 principles. Like I said, I'm not going to go into all of them. We won't have enough time. But I highly recommend having a look if you haven't heard of them before. And I think it goes back to DevSecOps, the kind of principle of making sure that you're integrating security and user advocacy in every stage of the user's journey within your application. So there's privacy-embedded design, respect for user privacy, keeping it user-centric, visibility and transparency, full functionality, end-to-end soft security, and privacy as the default setting, and making sure that you're proactive rather than reactive. And there are really cool diagrams that show you how you can implement this into a software development lifecycle too. So if we're working by these principles, then privacy is seamlessly integrated into the products and services, because we're protecting user data is guiding us in how and what we're building. So we're taking that into consideration, we're taking it as seriously or to the same level of importance as the functionality of the things we're building. So why is that important to developers, and how do we implement that? If we think back to our responsibilities, being user advocates and being able to include and kind of empower a user to feel safe when using our applications, it means that we're encouraging people to remain safe online. And we're also making sure that the less valuable data we're storing, the less we're mitigating some risk in advocating for privacy. So practically, that means we can be thinking about it in the design, system designs, in the product objectives, in the standards and protocols, and the business practices as well. And now I'm going to move on to another cultural shift that I think will make your security culture a lot more resilient, which is recognizing progress internally. Again, it seems really simple, but you'd be surprised at how little people do it and how much of an effect that has on people's willingness to participate in building a secure application. So celebrate your success. When a developer finds a vulnerability, make sure you're celebrating them and try to create that positive culture by making sure that these things, even if they're not kind of recognized by products, that's another kind of difficulty we can have in communication, is making sure that we're communicating, at least with engineering, that these things you've done are of value, even if the customer doesn't see them, even if the CEO doesn't necessarily know that you've done this. Like, as a team, as an engineering team, we should celebrate this. And so some examples are having a retrospective for something that's gone really well, and like celebrating reaching a certain level of test coverage, removing a security issue, and doing well in a pen test compared to previous. And these are all things that deserve recognition, and in recognizing them, you'll be empowering more people to continue driving that forward too. Next, we have increasing collaboration and sharing. So a thing that I think is a big problem with how we view secure development and security within our development of software is that we often see it as being down to a particular individual or subset of individuals. The more senior people, the people in DevOps, the back-end engineers, and in reality, security is a collective responsibility for the entire engineering team. So we need to encourage developers to work together and find and fix software development issues. And we need to do it in a way that encourages collaboration. So what are some of those ways we can do that? I think you should be having regular chapter meetings on security-related things. We have a monthly meeting for the entire engineering team where we get to come together to discuss the progress we've made in security, the issues that we wanted to flag, kind of any upcoming developments that are coming. And having those specific meetings for that cause at regular cadence means that anybody can be involved, and we're trying to democratize with an open agenda. So even if you're more junior, even if you don't understand anything, your question and your curiosity is welcomed and encouraged. Another thing I think you can do to make it social is have dedicated channels in Slack or Teams or Discord for your organization where you're able to share kind of social or like news media developments. It could seem trivial again, but I think creating those spaces where people can have informal conversation allows people to feel like they are applying their knowledge to real life situations, and all of that means that you're encouraging passion, you're allowing people with perhaps less knowledge to kind of enter the conversation, and it really encourages like the consolidation of knowledge. If there's a concept that's not quite sticking, and then somebody shares a news article of it being exploited, it can be a great way to like either take that person aside and have a 5-minute coffee chat and ask them about it, or just shoot them some questions directly in that channel. So yeah, I think it's great to have the opportunity to share those things. And then improving psychological safety. So Ava's talk was fantastic. She did a talk earlier about the line of code that broke the rocket. And she touched on this psychological safety because there was a line of code written by an individual, and the easiest thing to do there was blame them. And that's an example of not having psychological safety within a team. So what is it, and how do we cultivate more of it? Prioritizing psychological safety in engineering teams improves the retention, personal development, and innovation. And with security, it is crucial for an effective security culture. So what it is the ability to employ oneself without fear of negative consequence, of self-image, status, or career. It can be defined as a shared belief that the team is safe for interpersonal risk-taking. And I just want to make it clear, this doesn't mean that there are no consequences to failure and no consequences to mistakes. What it means is that those things don't damage our interpersonal relationships. They're not causing risk to our status or career, and they're opportunities that we can learn and grow from. And so having a lack of psychological safety within an engineering team means that you will not be able... Oh, okay, it's not a slide. So a psychologically safe team, people feel comfortable expressing their ideas, they make mistakes and learn from them, there's no fear of punishment, and they share more information. So there's more collaboration and better problem solving. Psychological safety and secure web development. So if we have fear of failure, that should reduce people knowingly releasing insecure code. Not quite. We actually find the opposite, that when there's a culture of fear within engineering, especially related to security, people are less likely to speak up about mistakes that they've made, and they end up trying to cover them and not necessarily feeling comfortable to ask for help. So where a mistake could have been mitigated or completely avoided, that person didn't necessarily flag it out of the culture of fear that you have. So making sure that team members feel psychologically safe, they'll speak up more, and this can help you to find and mitigate those risks sooner. And then, so we've got the idea of what psychological safety is and why it's important, but what are some of the things we can do to increase psychological safety? And one of them is making failing safe. So unlike the poor developer who wrote that line of code that crashed the rocket, we want to make sure that we've got as much psychological safety, and we're making it harder for failure to impact production. And in a technical sense, yeah, that means putting systems in place that mean that one dev can't take down production, although that is easier said than done. But it's a really important principle when we're considering DevOps processes. And the focus really is to reduce the blame on the individual and focus instead on the ways that the system can be improved as a consequence. At CyberSafe, we have monthly hack days, which are an opportunity for the engineering team to get competitive and try and build a whole feature in a day, and people get really into it. And there was a specific engineer who may have bypassed some testing or gone around and not quite checked the things she was pushing to production because she really wanted to get something done before a demo, and she ended up taking down production. So what ended up happening was, rather than blame that individual, it was a reframing situation where that person then had the ability to see the failure as an opportunity to learn further. There was a post-mortem where we were looking for the ways that it could have been prevented, as opposed to grilling that poor engineer about what she did wrong. And so that's an example of a learning from failure attitude. holding retrospectives and seeing it as an example of a way to create documentation, improve systems. It means that we're strengthening our resilience, but we also have the opportunity to strengthen our teams through empathy. So us humans, we have an innate need to feel cared for, to feel like we belong. And in community care within a team, we can show this through the empathy that we demonstrate in these moments. So rather than chastising someone, like was referenced in the talk, just having the opportunity to actually celebrate, well done, you took production down for the first time, or yeah, just making sure that it's not such a scary thing. And then finally, on psychological safety, we want to make it really easy to ask for help. We want to provide clear and accessible channels for communicating, and bonus points if you allow anonymization, although this can do it with caution, because it can introduce other issues too. But essentially, when we're creating the honest and open environment where team members can speak up, we're making sure that we're creating a team where people feel, or culture within a team where people feel supported and they feel valued and respected, which are all important aspects of being able to be experimental, develop well, and feel okay in making mistakes and investigating them too. So overall, psychological safety is crucial and critical for building a strong security culture. And to summarize, I think that security should never be an afterthought. We're seeing that the culture is shifting, and we are starting to see that it's integrated in every part of the build process, which is amazing. It's going to ensure that security is something that is first and foremost when we're considering things that will make a great application. And we've seen this with accessibility. We're now starting to develop much more accessible applications because accessibility is considered in the design process before that first line of code is written. And so I'd love to see that continue with security culture as well. Next, there's using secure development frameworks and tools. You don't have to build from zero. There's a wealth of stuff available for free, even for your side projects. Like, have fun with it. And just try to automate where possible and make sure that you're also taking the time to contribute to open source tools if you're able. And be empowered by threat changes, not paralyzed by it. Like we said in the beginning, it can be really easy to be overwhelmed with the pace of change, and it does move quickly, but so do we as a security community. So try and stay excited by that, try and have fun with it, try and explore, and create forums where you can share and discuss those developments so that you're able to stay more curious. And then, yeah, make it fun. Try to think about psychological safety. People will be their best selves when they feel safe at work, and that's a big part of wanting to be able and being able to do more in terms of security. Think about ways you can collaborate and make things more of a team experience. And yeah, again, with the social forums, just make sure that there are ways for people to contribute, even if they're junior and they haven't got very much experience in developing secure software. I will share, or if you want to take a picture of the slide, but I'd be happy to share the slides with you also. And thank you so much. It'd be great if you could give feedback and let me know what you liked, what you didn't like, and let's keep in touch. I'm Jessie Auguste on LinkedIn, and that's my Twitter handle. Thank you.